Okay, welcome to day 9, Advent of Code 2023. So, this one was quite a fun problem, and the differences between part 1 and part 2 were surprisingly small. So, let's dive in. Okay, so we are riding camel through the sandstorm, and we stop where the ghost's maps told you to stop. The sandstorm subsequently subsides. God, this is a right tongue twister. Somehow seeing you standing at an oasis. Whew. The camel goes to get some water and you stretch your neck. As you look up, you discover what must be yet another giant floating island, this one made of metal. That must be where the parts to fix the sand machines come from. There's even a hang glider partially buried in the sand here. Once the sun rises and heats up the sand, you might be able to use the glider and hot air to get all the way up to the metal island. While you wait for the sun to rise, you admire the oasis hidden in the middle of the desert. It must have a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone so the oasis can be around for the next sandstorm-worn traveller. Oh, this is a slog reading through these. Anyways, you pull out your handy oasis and sand instability sensor, or oasis. Oasis, yeah, I get it. And analyze your surroundings. The oasis... Yeah, okay. The oasis produces a report of many values and how they are changing over time, your puzzle input. Each line in the report contains the history of a single value. For example, this one. To best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a new sequence from the difference at each step of your history. And if that sequence is not all zeros, repeat the process. Using the sequence you just generated and the input sequence as the input sequence. Once all the values in your latest sequence are all zeros, you can then extrapolate what the next value of the original history should be. In the above dataset, the first history is blah 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 blah. Because the values increased by 3 each step, the first sequence of differences that you will generate will be 3, 3, 3, 3, 3. Note that this sequence has 1 fewer values than the input sequence because at each step it's considering the difference between 2 numbers, so naturally we drop 1. Since all these values aren't 0, repeat the process. The values differ by 0 at each step, so the next sequence is da 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 da. This means that you have enough information to extrapolate the history. Visually, these can be arranged like this. To extrapolate, start by then adding a 0 to the end of your list of zeros, because the zeros represent the difference between the 2 values above them. This also means there is now a placeholder in every sequence. You can then start filling in the placeholders from the bottom up. A needs to be the result of increasing 3, the value to its left, by 0, the value below it, which means A must be 3. So we take this number, we increase it by this to give us this number. Finally, you can fill in B, which is the result of increasing 15, the value to the left, by 3, the value below, which equals 18. So the next value of the first history is 18. Find all the 0 differences for the second history, requires additional sequence. It gets to 1. And then we do the same thing here, so we get 0, 1, 7, and then 28. So the next value of history is 28. Third, we get 68. And then finally, we have all of them, and we're going to sum them up to give them 114. So we analyze the OASIS report and extrapolate the next value for each history. What is the sum of these extrapolated values? So essentially, all we're doing is predicting the next value from the history, and the way that we are getting the next value from the history is getting the difference each time until we get to a full set of zeros. When we're at a full set of zeros, then we go back up the tree, adding on the difference each time, and then we get the final one there, and then we add all of them up. Essentially, that's all we're going to do. So we have this test input here. You can see my number is very large. So we have the test input here. We now know what it should be. So let's do assert solve with the test input. We'll assert that that is equal to 114. So that will be this number down here. Okay, so with this particular one, like I said at the beginning, it was quite a nice, fun problem to solve. So what we're going to do is we're going to keep a total at the top, and then we're going to go over all of the lines, each of these. So we'll do everything we need to on this one, then we'll do everything we need to on this one, and so on and so forth. So we'll just go through this, we'll keep getting the difference of all of them, and then when we have all of them as zeros, we then straight back up to the top. Cool. So let's give it a go. So for line in string.split lines, what we're going to do is we are going to get the each of the numbers. So let's say nums is equal to let's say list map int, and we are going to do that over the line dot split. So it's splitting it by space. That's going to give us all of the numbers. What we probably want to do, let's just leave it like that. Cool. And so then let's do the diffs is equal to an array. Oh, sorry, a list. I remember we're doing Python. Okay, so we're just going to keep going over the same thing until we get to all of them are 0. So we can either do this recursively, which absolutely we could do, or we could just do a simple while loop, which I think is the approach that I'm going to take. So while true, so if we have diffs and all, and let's do x equals 0 for x in diffs -1. So if everything is equal to 0, then we are going to break because we are finished. Otherwise, we are going to go with the start being nums if not diffs, else diffs -1. So what we're going to do here is we're just going to say the starting point for us is going to be the numbers if we have no differences currently. If we do have differences, we're going to take the last set of differences to work on the problem. So then we have this particular diff. So let's say the diff, and this will be equal to start index minus start index minus 1 for I in range, and let's do 1 to the length of start. Cool, so this will give us the differences between each of them. So we're starting at the first one, and we're then getting that minus the previous one for each of them. And then we're going to do diffs.append diff. That will then keep going until we get to the final set, where we have all of them being 0. So once we are done with that, let's make a new variable called ind for index. We'll set this to firstly the length of the diffs minus 1. So what we're going to do here is we're actually going to go over each of the diffs that we've got. We're going to then add in a new entry to the end and add on the new value for the next one using the one we've just added on, if that makes sense. So if we then do, so we're starting right at the very end. So if we do while index is greater than 0, I need to sort that out with my LSP. So diffs index minus 1. So we're already starting at the end, and then we're going in 1 so that we then add 1 to get to the end, or use the index to get to the final one. So we're using the minus 1, we're setting the minus 1's value using the current index we're looking at, and just going up the tree that way. So what we're doing here is index minus 1 dot append. What are we going to append? We're going to append the diffs ind minus 1. We want to get the last entry, and we're then going to add diffs ind, the current one we are dealing with, last entry. Then we're just going to do index minus equals 1. So this will then walk up the tree, add it, it'll be doing this step here, so we're adding up, adding a new entry onto each of these, going all the way up. Finally, we then do nums.append. So this will then be the final one that we want, nums minus 1 plus the diffs so we're just getting the final one in there, and then we do total plus equals nums minus 1. So what we've done here is we're just going over each of the lines. We find the end point where they're all zeros. We walk back up the tree, adding all of the numbers back on. So this is a lot of looping. Sure, there is a much more efficient way of doing this. Then we get the final values, and we then add it to the total. We then return the total. So this is quite a nice, easy problem, and here we go. We have solved it and got the correct answer for part 1. And as you can see, there is the value that we're looking for my input. Okay, so part 2. This is where I was very surprised that it was this easy. So, of course, it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well, right? For each history, repeat the process of finding the differences until the sequence of differences is entirely 0. Again. Then, rather than adding a 0 to the end, filling in the next value of the previous sequence, you should then add 1 to the beginning and then go backwards. Then fill in the first values for each previous sequence. In particular, here is what the third example of the history looks like when extrapolating back in time. Adding the new values to the left side of each sequence from bottom to top eventually reveals the leftmost value is 5. Doing this for the remaining values, minus 3 for the first, 0 for the second. Adding all of them together, you get 2. What is the sum of these extrapolated values again? So this one's going to be 2, so let's just go to, let's just go this way. So let's update the test. Assert solve using the test input, and that should now be equal to 2. So it's the exact same input that we're using, I believe. Yeah, the example data in the results. Yeah, so we start at 45. That's the one that this shows. Cool. So we have 2 here. So this is essentially the same thing. So if I just go back to part 1 and I just take all of this solve function, go to part 2, and then just pop it in here. So essentially, all we're going to do is change where we add it to on the way up. So while the index is greater than 0, instead of doing an append, what we're going to instead do is an insert at the 0th position. We are, instead of adding, we're going to remove. Instead of it being the last entry, we're going to give it the first entry. I'm going to keep walking up. Again, instead of it being the last, we're going to give it the first. We're going to use the first number to determine the determine the new number. Again, we're going to put it at the 0th entry, and we're just going to insert. That's essentially it. We also just need to make sure that we're getting the first new number. which essentially is what we're inserting there. So we could also just get away with not inserting and just adding it to the total. Yeah, so if I then run this using part 2, 20 does not equal 2. So what did I do? What did I do wrong here? So we go over everything. We then loop over. We get all the differences. And then from the end, we insert at the 0th position the diffs index -1 minus the diffs at index of 0, ind -1, and again the diffs 0, 0 plus equals nums. Okay, so let's do new entry equals nums 0 plus diffs 0, 0. And then let's print the new entry. Print. See, this is where I'm proven wrong by, yeah, it's really easy. It's a real simple change. And then I get it wrong. Okay, and then let's just add in new entry to here. New entry. Two, 3 to 15. That doesn't seem right at all, does it? Oh, I get it. I get it. There we go. There we go. That's it. And then let's just get rid of that print. There we go. 966, 966. So essentially, I just forgot that we were needing to remove the difference rather than add the difference. So yeah, there we go. That was a real simple one. Really simple changes. Instead of appending, we're inserting at the very beginning. And we're just taking away the first entry rather than adding. That's it. There we go. Okay, so there was day 9 of AOC 2023. Stay tuned for day 10.